Não, dá pra falar no aqui.
Hey everybody.
Yo.
Let me see. We are live. So I think that the sound may be a little too loud. Let me lower the volume a little bit. Hey Blind Joker, here who is? RH who is? How are you guys? Can you guys see myself and Gondo here? How is the volume? Gondo, say hi to everybody so they can.
Yo guys.
Can you guys hear Gondo okay?
Your neighborhood friend, Gondolindrim here.
Audio okay, alright.
Okay, nice.
Alright, so we are here because our friend Gondo finally received the PCBs, and the idea is, correct me if I'm wrong, to build one of them, right, Gondo?
Yeah, so our idea today is showcase kind of the prototypes for our PCBs in development. Show where the project is going, right? So our objectives, final objectives, what we pretend on doing, and show a bit of how the building process goes. Because, for example, I have here a almost fully built Keep PCB, right? So it has the processor, it has the crystal. The USB connector is still not soldered, which I'm going to do just now. This is almost the final idea, right? But the PCB itself comes something along the lines of this, right? So it doesn't have anything. So,
let me give you full screen. Give me a second.
Sure.
There you go. So you have it all.
So the idea is to show you guys how we go from this, which is virgin PCB, no components whatsoever, right? To this, to a PCB, fully fledged and functional PCB, right? This has been tested. It works 100%. What I could not test still was the LEDs, because I don't have SMD LEDs here with me. But I hope that you will do it when you get one of these. Also, I intend to answer general electronic questions on the design process itself and what we intend on designing those PCBs.
Very nice, very nice. So I have you right now on the top of the screen, and I'm towards the bottom where my face usually is. So
face.
Do you guys have any questions? Just let us know. I'll address them with Gondo, because I understand that Gondo is not seeing the chat right now.
Yeah, I'm seeing the chat. My screen's like half screen mine.
Yeah, you can see that I'm playing with my view right now. All right, so let's get to it.
So let's get to it. So what I'm doing right now is turning my solder iron on. And I'm going to solder this this USB connector. So what we do first is, it is highly desirable that we have a temperature controlled solder iron. The big problem is solder tin has kind of two major qualities. It is an eutectic mixture, meaning it is something along the lines of 37%. 37%, I guess it was 10 and 67%. I don't remember which one. But it has a fusion point right above 180 degrees. But we want a temperature controlled solder iron, just like this that Keeps gave me, by the way, because it gives consistent temperatures and hence consistent soldering points. So as you can see in the final product here, the solder points, they're shiny and clean, right? So the idea is that shiny and clean solder points mean that this PCB will last longer. And a major problem that occurs with these kinds of PCBs when the final user is building them is that the final user usually doesn't clean the flux on these. So, for example, I don't know if you can see in the camera there. I left some sockets with flux just for this purpose. I don't know if it's visible in the stream there. So that's the general idea, right? So show you guys how to solder these PCBs and how they're gonna. Our idea is that they are gonna come to you like this, right? So the only thing you have to do is solder the LEDs and the resistors if you want to, right? He's gonna solder all the hot swap sockets from scratch. Does it not come pre-assembled? No, they don't come pre-assembled. The PCB actually comes just like this. This is a virgin PCB. It comes literally virgin, no components whatsoever, including the microprocessor, right? So this is the pad for the microprocessor. It's real tiny, so I don't think the camera will focus just right. But and here is one that I soldered myself, right? So that's the idea. And answer the questions you guys have for us.
So yeah, for the prototype, Gondo is gonna hand solder all the prototypes, right, Gondo?
Yeah. So today I'm going to start with a Keeps PCB. If we have time, I may do an Arctic PCB. The Arctic PCB is this guy here. This one here, right? It is almost virgin, with the exception of the microcontroller that I soldered myself here. So first of all, we need to address the models, right? So we have two models here, which are the Keep PCB and the Arctic PCB. So the idea is that the Keep PCB is a hot swappable ANSI kind of board with the 7U bottom row, right? So three guys here, and a 7U bottom row, fully hot swappable. With LEDs, RGB, and all the kind of stuff. And the Arctic,
the RGB is underglow, right? Or is it per switch?
Underglow, both underglow and per switch RGB.
Really?
Yeah, it's kind of easily done because they are SMD, right? So the only problem is the firmware because it's fairly complex, but that's the idea. And then we have the Arctic PCB, which is this one, which should be a multi-layout 60% board, right? So in this revision, it is a single layout, right? So it is a standard ANSI layout.
So Sind is asking, what's the reason for the 7U space instead? We just wanted to do a hot swap that was different from what you find out there. So we did the Sangan bottom. That's the only reason.
That's the kind of only reason. The thing is, hot swappable PCBs, it's real difficult to make a multi-layout hot swap PCBs because since the PCB pads are SMD, they overlap each other when you are trying to do multi-layout. So it's very difficult to do that.
Mm-hmm.
So in general, hot swappable PCBs, they are single layout, right? So me and Keeps, we wanted to do something different from the general idea. And I mean, we can also do a ANSI 6.25 version.
Mm-hmm.
That's no problem at all.
Right.
But I don't think it is feasible a PCB that can support both Sangan and the ANSI standard. I'm just seeing the screw here. So the main features of these PCBs, they are basically two. First of all, which is very important and which I wanted you to test, Felipe, is the thickness, right? So these boards, they are thicker than the average board. What I mean by that? The average PCB is something around 1.4 and 1.6 millimeters thick, right? And these guys here, they are 2 millimeters thick. So I intend to test if this thickness influences on the sound and the full functionality of the PCB itself.
Right.
Right. So my theory is that the problem is generally the lighter part of the board is the PCB, right?
Mm-hmm.
In, let's say, high-end boards, the whole board and case is made of metal, which is fairly heavy. But the PCB tends to be the lighter thing. So it resonates, right? It can influence heavily on the sound. So I wanted to test if this thickness influences on the sound. Second of all is the finish. So as you guys can see, these boards, they have a golden finish, right?
Mm-hmm.
These boards, they are actually gold plated, nickel and gold plated. Also, the copper layer is thicker than the average PCB. The idea is that we have been receiving many complaints of people that try to reuse their PCBs, desoldering the switches or some component that failed. And it just so happens that desoldering is a fairly complex matter. So in many cases, you are trying to desolder some component and the pads lift. I think it happened to you, Kips, in a
Yeah,
recent
with
stream.
the Alps board, yes.
So when you have a thicker copper layer, this is difficult to achieve. It's more difficult to achieve because when a copper is thicker, the temperature it gets distributed a little bit more uniformly. So the pads tend to not lift as easily.
Right.
And that's the difference. That's the big features of these PCBs: the thickness and the copper layer thickness. Also, the gold-plated finish, which guarantees it lasts real long. So let's get to it. Let me just turn this thing on. There. Okay, so starting with the general guidelines for PCB soldering, first of all is you want, for normal applications, you want your temperature around the 330 degrees Celsius, right?
Hey, the CBN, welcome.
Yo,
300
so here it is, 330
Let me see what I use normally.
Yeah, so
I use 340, just FYI, and I think it's too hot.
Something between 300 and 350. That's the general.
But you know one thing that I noticed that is happening to me more and more?
What?
The flow, the flux, I mean, it's bubbling when I touch the... Is it because it's too hot?
Yeah, the problem is, so when you are soldering something, be it what it may, the metals, they tend to oxidize, right? So any metal you're going to solder has this oxide layer on top of it. So what do you need flux for? Flux is generally a light acid that peels this oxide layer and exposes the metal, the pad metal, so that you can form a chemical bond that the solder.
Does it also prevent solder from damaging the rest of the PCB?
Yeah, in some cases, flux may enhance the temperature building in the PCB. What's the big problem with soldering, right? The big problem with soldering is that you have 300 degrees Celsius in this tiny little needle-shaped thing.
Right.
So if you keep it too much time on the PCB, you may fry some component or whatsoever. But note that when you keep just touching the PCB and off and touching the PCB and off, you get cooling and heating it serially,
Right.
many times. So it damages the PCB. I mean, literally, it damages the PCB, which is why personally I don't like the hot gun air to solder stuff. The problem, you say, with the bubbling thing is that the flux being an acid and light acid diluted in water, it has a boiling point way below 300 degrees, which
Right.
we normally use. So what happens is that the flux is literally boiling. So
Right.
so the idea is that you use the least temperature you want in the solder. Ideally, you want something around the 310 degrees Celsius, but then we have the cold solder problem. If you don't heat the metals, the solder metals properly, you may have a bad connection.
So I think if you have good enough solder, around 300 should be good, right?
It should be good. The idea is to, so here what I'm doing is, this is flux, right? Have a liter of flux.
By the way, I have this flux. I don't think you'll be able to see it. I wanted to know if it's good enough. It's rosin flux.
Let me see.
Flux colophane.
Yeah, it should be. It should be okay.
What is the difference between this and a no clean flux?
The no clean flux is a flux that. Okay, so I just said that flux is a light acid, right? So being an acid, which is an ionic composition, it's conductive. It's fairly conductive. So you want something that, so in the board, it can make short circuits and things that you wouldn't primarily have and don't want to. So it is in periods that you clean your board thoroughly after soldering. But it's way too much of an ordeal if you are producing something in an industrial factory, for example. So you have these fluxes, which are called no clean, which they are not conductive. They don't become conductive, so that you don't have to clean your board.
Got it. Hey, Tefrem, welcome. And let me ask you the question that Sind is asking. I've seen videos where solder paste is used instead of solder wire. Is there any scenario where paste is preferred? What I think is for SMDs, right?
You would want paste when you are dealing with SMD components, right? So let me show you guys. I'm right in this right moment. I am soldering the USB connector, right? So it has two parts. The USB connector has an SMD part, which is really difficult to solder, and it has a THD part, which is fairly easy to solder. Right now, I'm soldering the THD part. The thing about soldering is that it really comes down, it boils down to temperature gradients. So the tin, it tends to expand and search for heat. It needs heat.
And by the way, welcome Tefrem34. Glad you caught us as well.
Welcome.
As you can see, I'm not this guy, but he's a guest tonight.
I'm not as beautiful as him.
And he's doing some PCB development with us. So he's soldering the components to the first prototype that we got. Just
so here it is, right? This is the THD part of the connector, and now we go for the SMD part. So Joker, the SMD part you see is really tiny, right? So the difference between the traces on the SMD part are something well around 0.5 millimeter. So it's really difficult for you to take a wire and then take your soldering iron, the tin and the soldering iron, and just solder them. So what we generally do is in SMD industrial components is we take a paste that has kind of some tin mixed with it, so that when you put heat on it, the tin just comes out. The tin is made on a paste, and it kind of glues to the component, and you don't have all the ordeal of soldering it really, really slowly and painfully, might I add. I personally don't like the solder paste because it adds an extra difficulty, which is using hot air. Sorry. Generally, with solder paste, we use hot air, and I don't quite like hot air because it adds temperature to the board, and it may damage it. It is then generally used in a controlled scenario with industrial complexes and stuff.
There are also those kinds of heat pads that you can put the PCB on top of, right?
Yes,
I've seen those things
the
as well.
the heat pads are meant just like for that to fully distribute the heat among the PCB so you don't damage it in the process of soldering or something.
It's too bad that we can't see what you're doing.
Yeah, so it's really tiny. I don't think that I can grab it on camera, but if you take a look, if you take a look here, you see that I tried to solder the SMD parts inside the connector.
Which part are you soldering right now?
The connector, right? So it has these
Oh, yeah.
SMD traces inside.
Mm-hmm.
That right now, since the iron is a little big, I needed a smaller needle. They shortened, they short circuited. So I need the wick.
Oh, really?
Yep.
That sucks.
Yes. But this is kind of exclusive to the connector because the connector, the traces, they are just kind of stuff inside it. It's really weird to solder it. But with the rest of the components, it's fairly easy to solder them, right?
So after you finish with the hot swap sockets, what's next? You're gonna do diodes and resistors?
Yeah, so we have the hot swap here, right?
Mm-hmm.
What this board needs to finish are the diodes, right? Are the diodes. The resistors, they are used only if you want the LED lighting.
Oh, nice, interesting. Got it.
You see? So the idea is that the resistors, they are meant for limiting the current on the LEDs. See? So if you take like 5 volts, which is the usual value of voltage on a board, on an USB connection, if you take just a LED and connect 5 volts to it, the LED will probably just blow off, blow up. I mean, it blows up. Because it conducts a fairly high amount of current. So you need a resistor to limit this current, which is the function of these resistors here, right?
So usually you use resistors when you need to limit or change the current?
Yeah, right, exactly. So
Either up or down or no?
I'm sorry, I didn't catch that, right?
So, I was asking, is there, so you use resistors or resistors when you need to bring the current down or what?
Yes, when you bring the current down. So if you take, for example, a red LED, right? When you go to the data sheets of these LEDs, they have two main parameters, which are the forward voltage and forward current. What I mean by that? So the forward current is generally the operating current you want the LED to work on, which may come from 5 milliamps in ultra bright LEDs to 20 milliamps on 5 millimeter normal LED.
Mm-hmm.
In keyboards, the switches, they are generally designed to use 3 millimeter LEDs. So you will generally use something around 5 to 10 milliamps at most.
Okay.
And the forward voltage would be the voltage these LEDs would output at the forward current.
Right.
So those are the main parameters for LEDs, right? So for example, I have this guy here. See, so I have a diode here that I'm going to solder right now.
Are you doing SMD or THT? I didn't see.
In this revision, it is CHT, right? So
okay, THT.
the pads, the Keeps PCB pads, they are both SMD and THT. I think you can see.
Yep.
Here,
No, I've seen
right?
seen those. Yes.
So they are both. The idea is that the switch diodes, right? They are SMD. They are going to come assembled for the end customer, right? So are you going to receive? A board, something along the lines of this, with the diodes on.
Right.
What are you going to do? You are going to, if you want to use LED lighting, per switch lighting, you are going to use resistors and the LEDs themselves, right? Uh, we still need to discuss if the PCB will come with the underglow LEDs under it, right? Here, or the user himself will solder these underglow LEDs, because I reckon not everybody is going to use the underglow.
Right. So is there a different spot for underglow, or is it the same spot as per switch?
No, it's a different spot, right? So the
Okay.
per switch LEDs usually come right under the central
Exactly.
hole. If you take a look at
Yep.
this central hole here, for example, let me see. This guy here, the switch LED is this guy right under it, and under the switch LED is the resistor for this LED.
Oh, got it. And
The
where do you
underglow,
have the underglow? Do you have on this revision the underglow as
usually
well?
comes in the back of the board, right?
Okay.
Because you are going to use it, something like this. So it comes in the back of the board. And you usually have something of 2 lines of 4 of them. So 4 here and 4 here. That's usually what happens with the underglow, right?
Also, you don't have a spot for that like you have for the underglow.
Not in this revision.
Yeah,
right?
that's what I was. Yes, that's what I was.
Almost surely.
Yep, got it.
So what's the idea here? The idea here is that, so I'm going to solder this diode here, the simple diode. The idea is that we keep heat in contact with the board in the least amount of time possible. That's the idea. So what we do is we put the LED on. Remember that the LED, the diode has a polarity, a correct polarity. What I have here is a 45-degree. I don't know if you can see a 45-degree.
I think it's called swivel tip or something like that.
Swivel tip, yeah, I guess so.
Yeah, something like that. I have one of those as well.
So the idea is that you take the idea is that the solder tin has to adhere to the component, not the iron. You don't want tin in the iron. You want tin on the component. So you heat the component.
Oh, sorry. I think I lost you for a second. I did something wrong and
No,
locked the machine. Now the screen sharing is gone. That happened to me before. I don't know what to do. Let me see. I'll stop the stream real quick, guys, and I'll try to restart OBS. Hold on. I think we're back.
We back?
Yeah. Not online yet. I'll let you know when.
Sure.
Let us know if we're live, guys. Oh, we're live now.
We live, nice. So as I was saying, the idea is that we want to keep the soldering iron the least time possible in contact with the PCB. So ideally, you want it in the PCB for something like 2 or 3 seconds. That's the idea. So the process is, the thing is, many people do it wrong, and that usually leads to some complications, right? which is they tend to put tin on the soldering iron and then on the component, and that's wrong. What you need to do is heat the component. The idea is that the tin, the solder tin, adds to the component. So that's what you want. So you want to touch the iron, the soldering iron on the component, and then from there the tin. The problem is the correct process takes some time, right? And people are generally not up to doing it. Yeah, so these are ideal soldering points you'd want on the PCB. Let me see if I can show you guys. You see this guy here, for example. Where is it? Here. So you want solder points, they are fairly small. They are fairly small and bright and real shiny. If the soldering point is like a blob or a little ball of tin or it is kind of opaque, right? That's what we usually call a cold solder.
And Sind is asking if you solder the tip of the iron. I do.
Yeah, you have to tin the iron tip. It's mandatory that you do because...
And I just figured out that last time I forgot. Mine is really dark and oxidized, so I will tin it right now.
Yeah, so you have to clean it first.
How do you clean it?
You don't want oxide on the
So how do you usually clean yours?
With this guy.
Yeah, I have both this thing and I have the brass sponge as well.
Yeah, so the brass sponge is abrasive. So you have to clean it with the sponge and have it real shiny, and then you tin it.
Okay.
Like this, right?
Yeah, I'm on the process of doing that right now. I'm cleaning it first.
So you should always, even
look at the difference. I don't know if you guys can see, but it's shiny now. It was really black with a lot of oxidization. So now, or oxidizing. Now I'm gonna tin it before.
That's not good. You want, because the thing is
I even have this thing here, which is a tip tinner. You see, you basically open it. Yeah. Let me show you. I don't know if you'll be able to see it, but this is a tip tinner.
Yeah, that's good. That's good.
So it has this little paste that you just stick the tip there, and then it tins the tip.
Yeah, the idea is that the soldering tip is made to conduct heat, right? That's the idea, conduct heat. So you always want it clean and shiny, because it's oxided, and when something oxides, it generally becomes gains. The oxide generally makes pores on the surface, right? It makes this, how can I say, coarse surface, not a clean one. And that's problematic because clean surfaces are better to exchange heat. Right. They're generally better to exchange heat. So even when the tin is off, it's not turned on, you want it clean and shiny, real shiny. Even when it's off. So when you finish using your tin, you want your soldering iron, you want to tin it and leave it tinned. And have it cold tin.
Okay, and Sin has an interesting observation that I think that I know the answer to. He's saying that the solder is not sticking to the tip of his iron, and that's because it's already oxidized, right?
Exactly.
I'm gonna send him a very good video about that I watched these days.
The problem is that the tin is going to catch, it's going to adhere to metal. because this tin is actually I don't know how to call it in English. It's a mixture of metals. We call it amalgama in
Alloy,
Portuguese.
alloy.
Alloy, right? That's exactly it. It's an alloy, so it will stick to metals only. That's exactly why it generally has flux on it to destroy oxidation, right? So clean surfaces, so tin will adhere to clean surfaces. If it's oxidized, it won't stick to either oxidized or cold. You want something that's clean and hot because the tin will pursue heat. It will pursue temperature, right? That's the general idea. That's why it's imperative to use flux. Flux is a good alternative, is a good tool to have because it helps you with the soldering process in the sense that it will destroy oxidation. It will peel off oxidation. Uh,
By the
Also,
way,
that's
I sent a very good video that I watched this weekend about how to revert the oxidation, I think it's oxidization process
oxidation.
on your tip in different, I think there are 4 levels of oxidation or oxidization. I don't know what's the proper word, but there are 4 different levels, and this guy, he has different techniques for each of them. So take a look. I think it's very nice video. It's called How to Clean Soldering Tip.
Yeah, so let's do this. So that's well another idea why I really stuck to the gold plating on these PCBs because as you guys may or may not know, I don't know, gold does not oxidize, not easily, not with so when you get your board to solder the components, it will probably be easier, right? There, yeah, there are kind of 2 finishes you can have in PCBs, right? So you can have a nickel plating or an gold plating. Nickel plating is nice, it works, but it generally is not as good as gold plating because it's nickel plating is usually thinner, and gold plating is usually thicker, and gold is a noble metal. So that's also another reason because why these boards they are golden, they are gold plated, right? The main problem with all these issues, it's not immediate. I mean, you're certainly gonna have a problem with the soldering, but also in the long run, having oxidation on your board and soldering oxidated components,
Oh man, I just did it again. I locked Windows. Give me 1 second, guys.
then
I'm trying to use the other computer as I'm using this, and that's not working out very well. So give me 1 second, I'll be right back, guys. Deixa eu adicionar ele aqui para ver se dá.
temp.
Can you guys hear me? So I think.
Yo.
Okay, so share your. Oh no, who is this? Are you on, Gando?
Yep, I'm on.
Oh, I can see your phone now.
Well, that's problem.
Now I see my own screen. Give us a second, guys. We are trying to figure this out. Let me add Gondo again because I think he's gone. He isn't. Weird. Can you hear me, Arctic?
I can.
Okay. Let's see what's going on here. So Gondo is here, but I don't know what the problem is.
I'm the minute
Wix.
track.
We are having some technical difficulties here, so bear with us. Wix is gone? Okay.
Hello,
All right,
hello.
so we have Gondo back. So Arctic Fox is also here.
Hello, hello.
Yo.
So Weeks is gone. I'll ping him. I'll say, come back.
Hey, Wix.
Hey, there he is. People said you were
You're good.
gone. All right, I never left. So we are talking about the Keeps PCB, Arctic PCB, and while Gondo is building one of them. In this case, Arctic PCB.
Yeah, so I'm building the Keeps PCB. This very same PCB is the one I will send you, right? So you can build it. And
You don't have to solder the diodes if you don't want. I can solder them here. I have a ton of them.
Nah, don't sweat
Okay,
it.
if you wanna do it, do it. I'm just saying,
They make
don't
good
worry
conversation.
about me.
I worry about you.
You don't need to.
So
While you do that, let me see if I can find. Oh, my PCB stuff is up there because I wanted to see if I have that plate for you. Maybe I'll go there real quick and I'll be right back. Okay?
don't sweat it.
Give me 1 second. I'll be on audio, but I'll stop my video real quick.
Yeah, sure.
And I stopped yours instead of mine. There we go.
So what you want generally is a clean process that promptly adheres to the surface, right? So I think was Joker that asked about it. Are you guys seeing my video? I don't.
So Weeks, sorry, let me address something on the chat. So Arctic PCB is not hot swap. The one that is hot swap is Keeps PCB.
Yeah. So the idea is that we have two models, right? So Arctic PCB is a multi-layout. It's intended to be a multi-layout 60%, right? As it is right now, are you guys seeing my video? Because I'm not seeing my video. Yeah, so here I am. So this, as it is right now, it is an ALPS compatible board, which was much of a fight from Arctic because he didn't like it, which is totally fine. But as it is right now, this board is in a standard ANSI layout, and it works. It works. I have tested it. The thing is, what I want to change here, first of all, is make it MX compatible only, right? It's not going to be hot swappable because, as I said earlier, it is really, really hard to do hot swap multi-layout. It is easier to do THT. And as it is right now, it doesn't have LEDs. It doesn't have per switch lighting. So I'm gonna add it in the revision too. What's interesting about this board is that it's really clean, right? So one thing I didn't like about the PCB is that somehow it has too much information on it. I don't think you guys can see, but it has all these markings and annotations on which components are which and the model of the components. So every diode has written on it 1N4148, which is the diode model I'm using here, and it's generally used on the keyboard. But I want to take those out. I want to make it a clean board. As you guys may see, the Arctic PCBs, it's really clean, right? It doesn't have annotation. It's just a white surface, which is really beautiful. Also, it has the Gondolindrim Electronics logo on it, which is very nice, golden. And I'm going to add somewhere, maybe on place of this logo, the Arctic PCB logo, which I designed. So yeah, those are the two projects, right? So a multi-layout 60%, which is Arctic, and a hot swappable tongue and bottom row hot swap board is the key, right? That's the idea.
All right, just to update you, I did find a plate I can send you. This is aluminum. Is that okay? Aluminum.
Yeah, it's fine. So I sold my N Pro, right? And I don't have a daily driver anymore. So I have this board here and case and everything, but I don't have the plate. I have a purple plate, which I guess you wanted, right? Or you wanted to use it, and it's yours. But I need something along the lines of a silver or gray plate.
It's okay. I can send you. I just wanted to send it to you along with the reset buttons. So let me see when that's going to come.
So here it is. As soon as you finish soldering the components, you want to cut the.
So I think
the
reset's
remaining-
gonna come tomorrow. Just FYI.
That's nice. So we can test it. And that's how it goes. But as I'm doing this with THT diodes, right? And our intention is to do SMD stuff later on for the diodes, for the switch diodes. The only thing that I'm going to leave THT are the LEDs themselves, except on the Keith PCB, because since it's hot swappable, we can't have THT LEDs, or else you will the switches won't be removable anymore, right? So we want LED LEDs, but the resistors for the LEDs will be THT in case the user just doesn't want to use them, right? So there will be left THT models. I really need to get myself a syringe for this. So as I was saying, Keeps, every time you take your soldering iron, you have to clean it. You want to clean it with the wet sponge, right?
I heard people saying that the wet sponge is not the best because it lowers the temperature.
Yeah, exactly. So the wet sponge, it cannot be soaking wet because or else it will lower the temperature. But if it's not wet, like soaking wet, it is just a little bit, say, humid, it won't lower the temperature itself. Also, if you have a controlled temperature iron like this one, it won't be much of a problem actually, right?
Okay.
The problem with flux is that it evaporates rather quickly, so you want to do it.
Well, that's very nice, Weeks. Make sure you count our PCBs as well, because we're gonna join this thing. The link's 50.
So in the next streams, I want as soon as we have the like definitive V2 versions, my idea is to also stream the building of PCBs, right? So we have a lot of time to talk.
Oh yeah, as soon as I get a Keeps PCB, I'm gonna try to either print a case for it or fit into one of the cases that I have, and then we're gonna make a build, which is not a build for Keep, but even for Arctic, I want to do that. I want to do like a soldering for Arctic PCB.
Yeah, the big problem with them right now, as they stand, is that they have the dimension problem, right?
Oh yeah.
I took the template of, I think it was the ZL PCBs, I'm not sure. And somehow they don't cut through the stabilizer cutouts. So if you take a right look here, right, so you have the stabilizer cut out of the spacebar here and the backspace here, right? As it so happens, most PCBs, they are just cut right in the middle of these cutouts. And for some reason, the Zio PCBs don't. Maybe because their cases are tailor-made to the
Yeah, but the
to their.
Zio 60 should not be tailor-made. So let me get a Zio 60 here. I have them, one of them.
Yeah, try it. It should cut right through the stabilizer holes, mounting holes.
Yeah, I have a Zio 60 here. I'm gonna take a look. Hold on. Oh no, they are cut.
Yeah,
Let me bring you back to side by side so I can show this better.
that's the
Take a look
problem,
here.
you know.
You see how it is?
Mechanical, that's not nice. Yeah, I'm seeing you.
And same thing for the space bar. Here we go.
What I don't like about it is that your typing force, it gets condensed on the stabilizers, right? That's exactly their point. So if you have a circle that's cut and it has like sharp edges, the force will it will concentrate on these edges. And I don't like that personally. I don't know. I find it very discomforting. So I try to do the PCBs without cutting on these holes, but it seems that it's just not possible. We'll have to do it. So that's no problem. So as in this prototype, first prototype, the PCBs, they don't fit any case. I have something along the lines of 3 cases here tested them with, and they didn't fit 2 of them. They fit just 1. So
Yeah.
we won't be able to sell them right away. We'll have to wait for the revision 2. But
Yeah,
that's fine.
but I think we'll have to compromise on something, right, to make it compatible with other cases, right?
Yeah, that's what we're going to have to do. We will have to make the PCBs, the dimension of the PCBs cut right through the stabilizer hole. There's no choosing on it, right?
Yeah.
We can't choose on that. But I think in the first revision, the first prototype, it is acceptable to need the tailor-made cases, and these problems will be addressed on the second versions, right? I also wanted to make some comments about the cleaning. So as I said, the problem is that the flux is generally a light acid, meaning that sometimes it's fairly conductive, which can short circuit something in the board and make some undesirable effects. But it will also have long-term effects in the sense that it may corrode some junction or some plastic on our board, which
Sorry.
is worse.
So I took you out. I opened Wix links when I shouldn't. Give me 1 second. Let me bring you back. Sorry. So you were saying, I'm sorry.
I was saying that when you are done with your PCB, you want to clean it thoroughly, right?
Oh, yeah.
You want to
Do you use like a toothbrush for that?
That's not advisable, right?
Really?
Why? Okay, so I will give you a fairly simple example. So let's say, kids, you dropped, let's say, coffee on the floor, right? So you were drinking coffee and somehow you tripped and you dropped some coffee.
I don't drink coffee, man.
You don't drink coffee, but let's
I'm
just take it for the
kidding.
sake of the argument.
I'm just
It can be anything.
showing the 2 that I had like on the last hour.
So let's say juice.
No, I drink coffee. I was kidding.
Okay. So let's say you drop some on the floor, right?
Right.
The problem is that how do you want to take this coffee out? You want to retain it? You want to take it away? or you just want to dilute it on the floor. So if you take water, suppose you take water, a bucket full of water, and then you just drop it on top of the coffee. You agree with me that the coffee, it will just get spread all over the floor, and probably it will get like sticky or smell or even damage the floor if it's made of wood or something, right?
Mm-hmm.
So let's take this metaphor and put it on the PCB. So you have it's something that you want to take out of the PCB.
Yeah.
If you just drop huge amounts of alcohol on it, the flux will just get all over the PCB. Sometimes it can get sticky.
I noticed that. That happened to me.
That's really not a good case because it can corrode the PCB itself. So as you can see, the PCB has it's kind of a varnish, like a plastic rubbery varnish, but it's plastic, right? So if you have flux, which is a light acid, all over the PCB, it can corrode this varnish, and sometimes it can corrode the connections. In the long term, this means that in 2 or 3, it's really not deterministic, right? I can't give a right number, but in 2 or 3 or 5 years, your board will maybe stop working, or some key will itself stop working, and you will be left with a.
How do you advise we clean it?
So what you do with cleaning? So first of all, I have some spare. I call them legs, right? I don't know, wires from the diodes I just soldered. So the first thing you want to do is cut these wires. So really flush to the board, right? Something like this.
Do you cut the solder as well, or not? Only the
wire? No. Try not to cut the solder, just the wire, right?
Okay. Yeah. I'm asking because in certain applications, people cut the solder too. If they want to sit flush on top of a case or something like that. Not for keyboards.
Not good.
Not for
not
keyboards.
Good.
For another other videos that I was watching these days.
I don't think you guys can see, but aside from the flux of the tin, which is kind of brown, kind of how can I say it? It really looks like a burnt liquid, or right, real brown. Aside from that, I have the flux that I have just applied. Okay, so in the sense that in your stream, and I told you that you didn't want to do that. You had a spray of alcohol. That's not what you want to do. It's quite painful. It's not the most how can I say,
pleasant or easy
fun way to do. But this is a bottle, half a liter of a isopropyl. So I'm just gonna open it. Steps to care to take. So this, if you smell this, it can get you dizzy. It's really strong, so you want to keep your face kind of away from it. Also, it's highly flammable, and it's fairly easy to boil. It has a really low boiling temperature, so you want.
So let's make this a happy hour. Cheers.
Cheers.
Let's smell this.
So
I think it's even the same brand that we have. Look, but I have
it's
the
a
1
nice
liter
brand.
one.
Plastic from Brazil.
Yeah.
So generally, in industrial facilities, the
Wix is breathing some 99%.
No, never breathe it. Never breathe it. If I'm correct, it's kind of toxic. Also, it doesn't get you a trip.
All the fun things are toxic, man.
Yeah, you won't get crazy on it. I'm sorry, you won't get a trip on it. You will just pass out or something. You get real dizzy. It's not nice, believe me. Ask me how I know it. The thing is, you want to take a cotton ball, right? So say normal cotton. Get your alcohol and you want to wet.
I think he's got incoming messages.
And you want to wet the cotton.
Gondo, we lost you when your phone rang.
Yeah, so I think someone called me, but are you seeing me?
No. Oh, now we are.
Yeah. So you have this cotton ball, right?
Blind Joker, we got it on Mercado Livre. I got it on
Yeah.
Mercado Livre at least.
The cotton ball? No, I am not hearing you. Let me just. Yeah. So you have the wet cotton ball from
Okay.
the alcohol. And that's exactly what you imagine. So you want to clean the board with this alcohol, because what this alcohol is going to do. So in our milk metaphor, in the coffee metaphor, what's the right thing to do? You get a wet cloth.
We lost you again.
Right? And you clean the coffee from your floor. That's what you want to do. You want to retain the coffee. You want to take the coffee out of the floor. In the same sense, we're going to use this cotton ball, because what's it going to do? It's going to take the flux out. It's going to retain the flux.
Okay.
Right?
So do you do it like this? Like you do like a small... Or do you scrub it? Do you scrub it, or do you just...
It's really just a small cotton ball.
Right. But do you do it like this, or do you scrub it?
I'm sorry, dude. I'm not seeing you here. It's like working or some stuff.
I was just thinking, if you tap it, you tap the cotton on the board, or if you scrub it.
No, you scrub it.
Okay.
You scrub it. You want to scrub it and take the whole thing out.
Got it.
What's the big problem with this is that if you cut the spare wires from the components, right, they are going to leave some sharp edges.
Right.
So you can get hurt. So take some care, right?
Mm-hmm. Yeah, and it usually what happens as well. Can you hear me, Gondo?
What's that?
I was asking, sometimes what happens to me is that the cotton gets stuck on those wires that you cut. So the cotton starts to disintegrate in all of the wires that you have.
Take a larger cotton ball.
Okay.
So if you take a larger cotton ball, let me see, like this.
That makes sense.
So I'm going to take a really large one, right? See, it's kind of almost the size of my palm.
Mm-hmm.
You wet it. So get it kind of wet, and then you just start scrubbing stuff.
Right.
I wish I had like a top camera like you do, so I could show it more easily. But let me see if I can show you guys. But it's just like it seems. I cannot see myself right now. So yeah, so see, I have this, and it's just, you just.
Yeah, I think we lost your sound for a second, but we can see what you're doing. Yeah, me 2 weeks. I don't do that. I don't even have cotton balls here, I think. I bet my wife has a ton of them. I just need to borrow them.
See?
Yeah, I see it.
Let me take this one. See, it's real shiny. You don't see anything anymore there. Important that you do this, because again, the flux is a moderate to, so it can part. And after you want clean,
we are losing you. Now you're back. Okay.
Back. So you want to clean it off. So, and that's it. That's just like a Sisyphus job. You clean it, and then you dry it, and then you clean it. But it's really important that for the longevity of the board, that you do this, because it's going to guarantee that the board will work for years, you know. Mm-hmm. I have seen problems in keyboards that were bought, like the guy bought the keyboard months before, and then it starts showing problems because some connections were off or corroded by deep flux, you know.
Yep.
Myself, I am real picky about that. I'm really picky about the flux thing.
Oh, I
So
never
what I do
realized.
generally is that I pass my my builds through a magnifying lens. So I have this stuff here.
Oh, Wix, nobody cleans their boards. I know that.
What's that?
No, Wix is saying that I tried once with a brush and never tried again, and it's the same across. I think most members of the community, they don't clean after their flush.
You should clean. You should clean always. Your volume is kind of low for me. I don't know why.
Am I low for everybody, or is it just for him?
I'm
Maybe.
not seeing the chat right now, so it may be that it's
Do I
it's like
sound
just
loud
for
for
me.
you guys? Let me see what I'm doing here. Output volume. Yeah, so I think it's something on your cell phone.
Yeah, it's on my side.
It is because I just double checked.
So let me just change the background on the phone here. Let's see if this works.
Okay,
Yeah, I
I'm
guess.
talking now. See if you can hear me.
So anyways, what I do is I use a magnifying glass to take a real look at the PCB to see if there aren't any flux traces left. And in this guy, it seems there are none. Yeah, so this is a clean soldered board, right? That's what you want to achieve generally. Now let's clean the top part. You see what I should do? What am I gonna do? I'm going to leave some connections with flux, and then take a picture so that we can publish the picture together with the video keeps.
Mm-hmm.
So you guys can see the difference.
I don't know
clearly.
how long you can endure that. I don't know if you're able to leave flux the way you are with that. Can
What's
you?
that?
I was asking if you're able to do that. If you're gonna be able to leave some flux on the board and not be bordered.
Oh no, my OCD is gonna trigger, man.
Oh
but,
yeah, that's what I'm
do it-
talking
I'll
about.
do it fast. So yeah. So that's it. That's basically it. You want to solder things, and then you want to leave a clean board. I also have to alert you guys to fluxes. So there are many fluxes that are really aggressive, in the sense they are really acidic, and they're fairly conductive. So it's the case that I have seen some guys build boards
Hold
with
on.
these
I pressed the wrong button
strong
again and
fluxes,
you're gone.
and then the board just doesn't work because somehow the flux has made a short circuit between 2 points that it shouldn't, and then the board just doesn't work.
Guys, I'll stop the stream and be right back. I did it like 3 times already. 1 second.
My audio is really low. I quite don't know why.
Yeah, and I was
The
checking
stream is
the
off?
volume of the call itself, and my input is at the highest level.
Is the stream off?
We're coming back.
Okay, so I'm gonna leave the call and get you back, right? Let's see if that works.
Perfect. Do it.
Yo.
How is it?
Yeah, that's way better.
Oh,
yeah.
nice. Now we can communicate. Yeah, and Wixa was saying that he's very, he likes that you're concerned about the quality of the PCB, which we are also thankful for.
Are we on already?
We are.
So yeah. So the thing is, myself, I'm not a wealthy person, right? So keyboards for me, they are kind of a luxury. I don't have the luxury of having like many keyboards. I'm a PhD student. I don't have money. So the thing is, I really need to exchange boards. So I started with N Pros. I have just sold them, and now I'm starting to get some like serious custom, like a tofu, a 5 degree. So I'm really concerned about the longevity of the boards, right? Because if I lose a board, I just lose the investment I made on it. I'm not going to be able to trade it or sell it. And from what I have seen, it is a fairly common problem in the community that the keyboards, they sometimes just stop working. And I don't want to point out names or brands or stuff, but I have seen like real famous boards that have some real bad design choices. And the moment I saw that, I was like, yeah, I need to design board for the community. Also, we have the problem with the Brazilian community that's really limited. So we have that. And so to make a long story short, the idea here is to build a affordable, good, quality PCB that you can be assured it will last long and it will work properly and you won't have any problem with it.
Yes, and
Also,
what Gondo is trying to say is that if we get this PCB, we're going to charge the Brazilian community 60 cents, and for everybody else, it's going to be $1.50. Okay.
60 cents.
What?
Yeah, the thing is, what
I'm
I
messing.
have,
It's
just,
I'm
I'm
messing with
just,
the
I just got it.
Jesus
I just
switch.
got it. So, yeah, I don't think you guys know, but we have done a private GB, right? With 60 cents a piece. But the thing is, I want to offer some affordable stuff
Oh
for
yeah.
the guys. And the main problem with keyboards, in my opinion, is the PCB because the keyboard, the keyboard hobby is 99% about looks, about how good the keyboard feels. Not looks, I mean senses. You know how good it feels, how well it types, how well it sounds, how good it looks. But most of the users in this hobby, they don't quite care about the intricacies, the technical intricacies, like how is the PCB made or how well it is designed. So, and I have seen that this leads to a problem that the PCBs, they are not generally well designed. So I want to make a quality product which is affordable, especially for the Brazilian market.
Oh yeah. And that's a
If
very
you,
very nice and generous thing. And the reason I am proud to be part of this is to enable a community that doesn't have a lot of access to those things, right? So that's our first goal, to make something that, as Gondo said, it has quality, but we don't compromise quality because it's cheap, right? I remember before Gondo joining us, there was this GB for I don't remember the name of the cheap 60% that is open source.
I don't quite get that. Also, sorry, I don't know it.
Oh yeah, Laplace or something like that. Laplace 60. I don't know if that's the name. Anyways, that thing was gonna cost like $35. It's not GX60. It's an open source. I think the name is
Sure.
Laplace or something like that. Laplace 60. And so they did a GB that would cost $35. That's not cheap, right? That's like
Yeah,
that for that price you can get a DZ60, for instance, which has underglow and everything. Oh yeah, and see,
sure.
I saw that with Jesus that it's now 60 cents again. Yeah, after mass drop, they when they come and they
Yeah,
do like the roundhouse
the,
kick from the what's the name of the
the
guy?
famous Panda Gate.
That was like the final, the finish him from Mortal Kombat. That was the
Yeah.
last nail on the coffin.
The thing is, I don't want to judge the guy. I mean, I'm all about free market, but the thing is, it left this sour taste in
Oh
everyone's
yeah,
mouth that it was quite clear that this guy was trying to profit off of the meme switch, right?
and now that he lowered, he went against everything that he was saying so far, right? I feel
Exactly.
like he just said, you know what, you guys are right. I'm I don't want to say this word, but I was indeed trying to get advantage. If I was him, I would stick to $1 and keep the price, and just I don't know.
Yeah,
If
the
I was
problem
him, I
is,
would not charge $1 for
I,
50
I,
to start
the
with.
thing is, I try not to judge, right? So we have to see this through a real cold and uh, 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 objective inspection. So this guy, he made an investment. So from what I understand, he had like a whole batch on, like he pre-bought a whole batch of switches and he had boxes and boxes of it, hoping to sell them. And it's nice because it lowers the shipping time. It's real nice. What I got, like the only thing I had to say was that it all went down with so little transparency, right? So he just put the price, and that's the price, and then
Oh yeah, no.
people ask,
If I were him, I would say I did this for my friends for 60 cents. I want to sell this as at 150. And just if you're transparent, people are gonna understand you. And the reason I'm doing this is so that the community can get another batch, maybe. But he started this thing with MOQ for something that doesn't even comes in batches. He already had the switches. So it doesn't make sense to have an MOQ, right? I don't know. Again, as
yeah,
you said, I don't want to
the
judge,
thing
but
is,
from the outside, from where
I
I'm
think that
standing, I think he tried to get advantage of people.
I know what you're saying, right? But I think he understood that he was doing like shady stuff, and then he tried to amend it by saying there was an MOQ, but at the same time he already had the
Yeah.
switches there,
So it's
and
not
I
like
think that
his costs would lower with the quantity, right?
exactly he was just trying to put out some,
Yeah.
I don't know, some hype. I don't know.
Yeah. He was, as someone said here, he was trying to piggyback on the HP, the Holy Pandas meme.
The thing, right? Yeah,
Oh
but
yeah,
I
he was
think that
blackmailing Zondat because apparently he disclosed that he was doing 60 cents, right? Wix. That's what
I
I
didn't
heard.
know that he blackmailed the guy.
Yeah, I don't know. Yeah, that's just fucked up.
The thing that's the problem with. I think that's a big problem with this community. The makers in general, they are not accessible, right?
Yeah.
So, by the way, that's exactly why I stream. So I don't think the majority of the guys know, but I'm designing a open source 40%, which is a Shark PCB, and I'm streaming the design. So I want to have contact with the community. I want people to ask me why I'm doing the stuff I'm doing, and be transparent about it because I want this community to thrive. I don't want to profit off of it. But I don't know where the profit thing goes, and I don't know where exactly is the line between hobby and profit, right? Because we know we have um, huge stores like Novelkeys, Pimp My Keyboard, Mess Drop itself, and it's good because when you have professional guys like these, they make professional stuff. They make
Oh yeah.
good stuff, high end stuff. But at the same time, people that take this as a hobby, they don't see it quite nicely because it's just a hobby, and you know, it's your hard earned money.
Okay,
So yeah,
Weeks. Why don't you start with your lube mixture? Let's make that public. I'm messing with you. I'm just messing with you, man.
but and yeah, that's quite it. But we are designing these guys just so that people can get a good product and transparent design process.
Oh, you did. I have to assume that I am not very active, not only on Dads, but I'm not active on Discord as much as I used to be. Not even on my Discord. People here know. I just been super busy. I'm kidding. I think you have the right to, if you find the mixture that pleases you, you have all the right to keep it to yourself. I was messing with you, like seriously. Um, but yeah, I as well want to start to open sourcing more stuff. I did open source the design, which is not mine, for the ping master. I want to do more of that. Since I'm not creating stuff, I want to try educate people on hand wiring. I want to try to educate people on doing cases, doing things like that. So yeah, I'm probably gonna do a lot more YouTube video on those topics.
Yeah, it's funny because I was like yesterday, I think, or some days ago, I was talking to Jack Humbert, the owner of OLKB, and the plank, it has an open source branch, right? So you can
Who's
get
this
an
guy?
open source, and uh, and I asked them, I said, yo, why don't you do like open source, full open source plank and Prionic? And he says, well, we have a problem with the big makers like KBD or
Oh
Keep
yeah,
Grab.
KBD fans will steal your stuff into.
it's it's not like they're not enemies or things that you just want to screw them over, but the thing is, if you make such thing open source, you basically just give up your work, right? They will take it and sell it.
It depends because
So
under normal under a normal scenario, you would be protected by law even if it's open source, right? But the problem is that in China, we all know that those things are not enforced, and it's a two-way sword, right? Because in one way, it's good for the community because it's bringing out a lot of cheap products. I have a lot of KBD fun stuff here. I'm looking right now at the tofu case, which is somewhat of a copy of the Fiel, or maybe not. Maybe the Fiel were a copy of something else. But the problem is if you disclose that and someone in China wants to use it for no price, it doesn't have to be KBD fans. It can be someone else, right? They're gonna end up using it.
yeah, and then that's the problem. Why don't I open source Arctic and Keeps? That's the reason. So the
So
big
Wix, you
problem are
bought
tree
50
designs
grams of
and
203.
what's that?
So Wix was saying that he bought 50 grams of the 203 um, lube.
That's a nice loop.
A lot of lube as well.
That's a lot of
So
loop.
Gondo, I
I'm
want to do a
wondering what
quick
you're
time
using.
check. I have maybe around 10 more minutes before I have to go. Do you want to like give a final talk about the boards? Any closing thoughts before we wrap this up?
Yeah, so the thing is, there are already a bunch of boards in the market. And why am I trying to enter a market that's already kind of saturated? You can get like a DZ60, a GH60, you can get a Satan. I want to do it out of transparency, so guys can know the product they're buying, even if they don't know the technicalities of engineering or
Mm-hmm.
the electric intricacies. And I want to, for the most part, talk to the community because that's a hobby, right? So you want to be active in the community. So my idea is to interact. So anyone can please hit me up on Discord
Yeah, if you
or
want,
in
our Discord is down here.
yeah, and if you also want to take a look on my Twitch channel, in which I do my streams, and the past streams I usually put up on YouTube, on my YouTube channel. And if you guys have any questions, if you guys want to know anything about the boards, so I'm looking for US and EU proxies to sell the boards if it comes to that. We are sorting some things out. We have a member on the Discord, Ubimit, that maybe could do EU proxy. So they might be available somewhere around March, maybe. I don't have a specific time. And the idea is that you guys input the problems. The guys input what directions you wanted the project to take, what you want to do with the board, ideas that you guys have. Please come to me with them, and maybe we can sort something out. We have many projects right now. So we have this guy, the Keys PCB, the Arctic PCB. We have the Pierma pad, which is a number pad. We have the shark PCB. We will have a staggered 40%, which I didn't name yet. And we have the elevate, which is in the works.
Mm-hmm.
And we are working on it. So
Exactly.
please hit me up whenever you have a doubt, any question.
Yeah, so on my side, I wanted to thank Gondo for his time, for being here. Really excited to receive one of those PCBs so I can build them on stream. And again, we have some dimensions, minor issues that we're going to fix on round number 2. That should be as soon as Gondo finish assembling those and shipping them. He's going to make the changes that are needed on the boards. We're going to most likely order round number 2, and then from that point we're gonna start the IC, right, Gondo, and hopefully the group buy.
Yeah. So the time working frame here is something around like in January we are going to finish the project. Somewhere around February we are going to do the IC, and if we have enough interest on EU and the USA, we may sell them on the USA. In Brazil, we will have an IC and probably a GB around February to March. That's the idea right there. These boards, they will cost somewhere around 30 bucks with the full LED and the whole.
Wix is bringing up a good point. He asked you to take a look at the stabilizer's orientation, so they support most plates. Another thing to look into.
Okay, sure. I will take a good look onto that.
All right. And thank you very much, Gondo, for taking the time and being on my stream. And I will make sure that I publish this to YouTube, and I also put the Discord link there so people can watch the VOD.
Sure, that's nice. Anyone that has any questions, please hit me up.
Perfect. All right, guys. Any closing questions before I let everybody go? Any closing thoughts? Anything? Doesn't look like it. So thank you to Frem34. Thanks, Weeks. Thanks, everybody. Thanks, Sind. Who else is here? Thanks. I need to have one of those scrolling credits thing. Arctic Fox. Who else participated today? I think RH Ruiz was here. Blind Joker was here. Yeah, thank you guys. And I'll try to. I was planning to build my key code number 1 today, but I didn't loop the switches, so I'm not doing that today. So when is your next stream, Gondo?
Okay, so my next stream will be on this Thursday, right? At
Thursday.
8 p.m. Brazilian time or 3 p.m. Pacific Standard Time.
I'll be there as a watcher. I wanna learn more about PCB development myself.
That's nice. We'll have fun.
All right. Have fun with the board, and I'll be waiting for you to ship mine, and don't forget.
Still this week, man. Still this week.
All right.
I'll be anxious for you to build it on stream also.
Oh, yeah. As soon as I get it.
No.
All right. See you guys. You have a good night, good day, good afternoon, whatever you are. See you. Bye-bye.
See ya.